Sir, I am B. Pursa from CSC B section. Here I am introducing the topic about queues using arrays. Next we are moving to the outline. Introduction of queues using arrays. Algorithm to insert, delete, display queues using arrays. Program to insert, delete, display queues using arrays. Output of a program and conclusion. Next we are moving to introduction to queues using arrays. When a queue is implemented using an array, the queue can organize an only limited number of elements. The first entered element entered into the array in the first element to be removed from the array. It contains three operations. For the implementation of queue, we need to initialize the 2 pointers, front and rear, enqueue operation, dequeue operation, and display operation. These are the operations. First operation is enqueue, whether queue is full. First we have to check about whether queue is full or not. Rear equals to size minus 1 is the if condition to check the queue is full or not. Then display queue is full. If it is not full, then increment the value by 1 and queue of rear equals to value. And next dequeue operation, check whether queue is empty. Empty condition is front equals to rear, then display queue is empty. If it is not empty, then increment the value by 1. Then display queue of front is deleted element. Next we are moving to display, check whether queue is empty, front equals to rear, then display queue is empty. If it is not empty, then define an integer I equals to front plus 1, display queue of I value by 1, repeat the same until I value reaches to rear. Next we are moving to program. Here is the program of all about uh, queues using arrays. First we have to initialize and operators, and next we have to use the do condition, and next while choice is not equals to 4, we are getting these all conditions as possible. Algorithm for void insert. If rear equals to size minus 1, printf queue is full, insertion is not possible. And next else, if front equals to minus 1, then increment the value by front equals to 0 and rear plus plus. And next queue of rear equals to value, printf insertion success. And next void delete. If front equals to minus 1 and not front is greater than rear, queue is empty. From these conditions we can say that queue is empty, or else front equals to rear also we can take. Next else, deleted element. Deleted element equals to percentage d q of front. From we are taking from q of front means percentage d. And next, if front equals to rear, front equals to rear equals to minus 1, we are incrementing and incrementing the front. Here we are using for deletion is front pointer, and insertion rear pointer, and void display. If from first we have to initialize I. If rear equals to minus 1, q is empty. Else front q elements are. We can display that q elements are front equals to I equals to front. First we have to initialize I value as front. I is less than or equals to rear. I plus plus printf percentage d slash t q of I. And next we are moving to output, insertion, deletion, and display and exit. First we have to enter the choice, that is 1, enter the value to be inserted, that is 10, insertion success. And next insertion, deletion, display, exit. Enter your choice 1, enter value to be 20, insertion success. And next we are moving the same as 30, and next we are moving the same, displaying the elements as 3. We have to use the option 3 to display the elements. 10, 20, 30. We are inserted the 10, 20, 30, right? And next we are moving to insertion, deletion, and display and exit. First we have to delete. We have to uh, do now delete. Next we are entering the choice as 2. Here we are deleting element 10. And next we are moving to display. Then 10 was deleted. That's why it is coming as 20 and 30. And next we are moving to display deletion 2. And next we are deleting an element 20 here. And next we are displaying the elements as 30. Only the q elements are 30. Next insertion, deletion, display and exit. Now we are deleting the one element as 30 and deleted element. Q is empty. And again we are displaying the elements, right? Q is empty, deletion is not possible. Next insertion, deletion, display and exit. Enter your choice means 3. Q is empty. In the previous one, we are displaying the elements. We are deleting the elements. That's why Q is empty. Deletion is not possible came. And next we are displaying the elements. Q is not possible. Q is empty. And next insertion, deletion, and display and exit. At the last, we are entering the choice as 4, exiting. Put here, and then conclusion. A conclusion of the program is to insert, delete, and display queues using arrays would typically summarize the key points and outcomes of the program. It might include a brief operation of the functionality implemented such as enqueuing, dequeuing, and displaying elements in the queue. Additionally, it can discuss any challenges faced during implementation and how they are addressed, as well as potential areas to improvement or further development. Overall, the conclusion would aim to provide a result of the effectiveness and efficiency of the implement solutions.